Hey there, and welcome to Home Reno Inspiration, where we inspire you to upgrade and fix your own home. Look, I get it. Sometimes you need professionals, but for most stuff, you can probably do it yourself. All you need is a little knowledge and inspiration, and you could do the job right too. In part one, I talked about how I'm using the NEC, or North American Electrical Code Manual, as my authoritative source. In part two, I talked about wires and how to calculate circuit loads. Today, in part three, we're going shopping for electrical cables at our local supplier. Let's get started. I said in a previous video that in home electrical wiring, we most commonly find three gauges of cable: 14, 12, and 10 gauge. Let's go visit Home Depot and find out how much this stuff costs. Here are my local spool prices. In Canada, spool distances are measured in meters. A meter is about 10% longer than a yard, so 75 meters would be equivalent to about 82 yards. As you can see, 14 gauge spools are the cheapest for just 123 bucks, and 12 gauge spools are almost double. 10 gauge, more than triple as compared to 14 gauge spool prices. Interesting. Maybe these are just Home Depot prices? If you deal with an electrical supplier who gives better prices, I want to know about it. Tell us in the comments below. Now, we can buy less than a spool, but then we might pay more. How much more? Let's check. These are the prices for 14/2 cable for shorter lengths. That's interesting. They do look more expensive. Let's put these prices in a chart to compare the cost per meter. Wow, look at that. When I buy something less than a spool, I'm paying what? Double? That's crazy. Spool prices are definitely the best value. If you're installing a bunch of pot lights like me, you'll probably need at least one spool, even in smaller homes. Or you could try and measure to figure out exactly how much cable you might need for your home. Now consider this. Most circuits in your home are 15 amps. The only circuits that are likely more are the electric stove circuit, maybe 30 amps, the electric dryer circuit, maybe 20 amps, and the air conditioner circuit, maybe 30 amps. And the reason we can tell is it uses a different receptacle, where we plug it in. So that means, like I said, most house wiring is on 15 amp circuits using 14 gauge cable. Why? Well, we now know why. 14 gauge cables are way cheaper compared to 12 and 10 gauge, like 50% to 25% of the cost of those other lower gauge cables. So what happens if we decide to save money and just use 14 gauge cable everywhere? Will it work? Yeah, great question. Let's look at the code. In Appendix B, Table 2, looking at our 14 gauge wire row and then looking down on our 90-degree column, we see that the maximum ampacity for our 14/2 cable is 25 amps. Why are we looking at 90 degrees? Well, our cable is NMD 90, where 90 is the max temp rating for our cable. But remember, we're at the limit of its rating and the code is listing minimum requirements. Generally speaking, if we wanted to maintain a comfortable 60-degree temperature so that we can stay well below the maximum temperature rating of our cable, then we would do as recommended in this table, which is for 15 amp circuits, we would use 14 gauge cables. For 20 amp circuits, we would use 12 gauge cables. And for 30 amp circuits, we would use 10 gauge cables. If you decide to push more current through your 14/2 cable, just follow this table and make sure you're at least meeting the minimum requirements. This table makes a bunch of assumptions here too. It assumes the ambient temperature is 30 degrees or 86 degrees Fahrenheit. It also assumes that you're mounting your cable on masonry, plaster, or wood, not metal or plastic. It assumes you're using 14/2 cable, which only has two conductors, and not 14/3 or 14/4, and that you're not bunching up multiple cables together for extended runs, like in a conduit. Basically, most home installations should meet all of these requirements. If your case is special, then look closer at this table and pay particular attention to the notes at the top for additional rules you need to follow for your special situation. Here's another question. Can I use a higher gauge, like 12 gauge, for a 15 amp circuit? Yes, we can. In fact, we're exceeding the code requirements. We'll lower the max temperature of our cables will experience because we're using cable with a higher gauge rated for, say, 20 amps on a 15 amp circuit. The drawback is, of course, price. We'll be paying double for our cable. Is it worth it? Probably not. If we went around our house and started calculating circuit loads, we'd probably find most 15 amp circuits in our home don't even use 50% of the available power anyway, perhaps even less. The only circuits that might experience close to max load would be circuits used for heating, like a space heater, or maybe circuits used for heavy equipment, like power tools or something. Our air conditioner, our electric dryer, and our electric stove are likely already on higher gauge wire installed by the builder of our home. It's a good idea to check to confirm this too, though. That's a good idea for a future video. Look for it. Now that you know these basics about electrical cables, you can examine the wiring in your home and determine for yourself if it meets the minimum code requirements. You can calculate loads. You can read cable. You should be good. If your current cabling isn't meeting these minimum requirements, then you have some work to do. Do you need an inspector to check your cable to see if it meets code? Hell no. If you can pay for a mortgage, I'm sure you're smart enough to inspect your own cable. Go check it out and tell us what you find in the comments below. Okay, there we have it. We went shopping for electrical cables and we now know what to buy and whether we're getting a deal. Perfect. I hope this helped you get started on your electrical wiring project. I look forward to your comments below.